Hello, my name is Houda Er-Retby. I'm research at School of Architecture, Planning and Design in University Mohammed Polytechnic. This work is a part of research activities at our university. It's about multi-objective optimization of a shading system to reduce heating and cooling energy needs of a house in Benguerir-Morocco, which is a relevant topic to the energy efficiency in the buildings. My co-authors. Our contents as follows. I will start by problematic, methodology and objective, case of study, results and discussion, and finally conclusion. The building sector considered as one of a major energy consumer in Morocco, accounting for around 33% of the country's total final energy consumption. Also, the orientation, construction materials, geometry of the envelope, roof, and floor, as well as the windows, can contribute to overheating or overcooling of the building. Therefore, a better disposition in an optimal orientation of the windows with a pertinent architecture can minimize energy needs of the building. Our work presents a methodology combining multi-objective optimization with MOBO and middle energy simulation with TRNSYS to optimize shading coefficient to reduce energy needs of an existing building in Benguerir-Morocco. As I mentioned, we worked on a sample zone located in Benguerir, which in turn is located in the 5th climatic zone that's characterized by a hot semi-arid climate. About the salient details of the zone, including the orientation, the areas of different facades, the windows area, and the composition of the wall, the roof, and the ground floor are shown in those two tables. The thermal study was developed by the dynamic thermal simulation software TRNSYS. Using the Simulation Studio graphical interface, we created a model which integrates all the types used for the dynamic thermal modeling of the building in a single simulation window, as shown in a figure. Move on to the simulation result. The first graph shows the variation of energy needs during 1 year, which equal 207 kWh per meter square. That puts our building in energy consuming category. And to optimize this highest energy consumption, we activated the coefficient of a shading surface and the TRNSYS. Due to the big losses through the windows, we fixed the value of coefficient in 1. This value of a shading coefficient affects our building positively, and it was able to reduce the heating and cooling energy needs to the value of 132 kWh per meter square in 1 year, as the figure 2 shows. Despite the reduction of these energy needs, our building remained in the energy consuming category, suggesting that the coefficient of a shading is not optimal. Therefore, we used an optimization methodology to obtain an optimal coefficient for the various windows of a building. We implement the two objectives functions that we need to optimize, which are cooling and heating energy needs, in MOBO tools using non-dominated storing genetic algorithms. After we are dealing with the two objective optimization, there are almost 200 Pareto optimal solutions as shown in the last figure. For heating, we found that the minimum value is around 43 kWh per meter square in 1 year, which corresponds to a shading coefficient value that equals 0 in all the orientations. This can be explained by the fact that in winter season no shading is necessary, so that the most of solar radiation can enter the building through the windows, thus increasing the solar gains and reducing the heating energy needs. On the other hand, in the summer season, we must shade the windows totally to avoid the overheating. Thus, we found the optimal shading coefficient is 1 in all the orientations. This value corresponds to a cooling energy needs of 80 kWh per meter square in 1 year. But when we minimize the heating, we maximize the cooling, and vice versa. Therefore, we found another solution that minimizes both of them, which equal almost 0.6. So, optimization of a shading coefficient can reduce energy consumption, but insufficient to make the building compatible with the RTCM requirements. Finally, it's worth to mention that optimization process considered in the present study did not consider many aspects, such as lighting, environment criteria, air quality, and geometry. These aspects will be considered in the future research to improve the performance of a building. Thank you for your attention.